Now, what's given in this question is that you're given the initial moles. These are the moles right at the beginning, and they told you that there was 4 moles of nitrogen dioxide that was put in a container. So 4 moles of this and 0 moles of this. These were not added to the container. And the reaction started. It was heated to constant temperature. The equilibrium mixture contained 0.8 moles of oxygen. So after, I mean, when you added NO2, there must have been some forward reaction, then some backward reaction, and then eventually an equilibrium was reached. The rate of forward became equal to the rate of the backward reaction. So at equilibrium, what is given is that you have 0.8 moles of O2. This is what is given. Okay, that's written over here that the equilibrium mixture contained 0.8 moles of oxygen. So that means that you didn't have any oxygen at the beginning, but now you have 0.8 moles. So what does that mean? That means that 0.8 moles got produced during a reaction, right? They got produced. Is this clear? Okay. Ahmed, is this clear? Anna, is this clear? Mariam, is this clear?
Yes.
Achha, so initially you didn't have any O2, but now you've got 0.8. That means 0.8 got produced. So that means there must have been some forward reaction. So if one O2 is produced, then two NO are produced along with it. So it's 1:2. So if 0.8 are produced, so over here, how much NO would be produced according to the ratio? What's the answer? Ahmed Abdullah, what's the answer? Zero 0.8 moles. Are you listening?
Yes, sir.
Achha, so one is getting one. If one O2 is produced, so two NO is also produced along with it. TK, if 0.8 are getting produced, so according to the ratio, 1.6 moles are going to be produced. So there's going to be an extra 1.6 moles of NO that is going to be produced. So initially you didn't have any NO, now you've got 1.6. So the net moles at equilibrium would be 1.6 moles. As similarly, if you want to produce one O2, how much NO2 should react? It's 2:1, right? If two NO2 react, then one O2 is produced. So if you want to produce 0.8, according to the ratio, 1.6 moles must have reacted. So that indicates that 1.6 moles are gone because they've taken part in the reaction. So how many moles do you have at equilibrium? You started off with 4, and now you've there's 1.6 moles that are lesser, so that's 2.4 moles. Is this clear? You've found your equilibrium moles of each substance. Okay, is this clear to everyone?
Yes.
Yes.
Anyway, so the last part is I told you not to use moles, use concentration. So it's a 1 dm cube container. So divide everything by 1 dm cube. It would become mole per dm cube. That would be concentration. Divided by 1 doesn't really affect any calculation as such. And what's your Kc expression? It would be NO concentration. I mean, it would be the Kc expression would be NO concentration would be squared product. O2 concentration would be power 1. And you're going to divide the whole thing by NO2, and its concentration is going to be squared as well. So the correct answer to this question would be 1.6 squared into 0.8. That's your product divided by your reactant, which is 2.4 squared. Is this clear?
Yes.
So let's try and do a similar question. Just 1 second. So I think we did this one. Let's try and do this one. So there's this reaction where N2 is reacting with 3H2. Now all of these questions are very similar. They're always solved in exactly the same way. So what's the situation of the container initially? How many moles of N2? So you added 1 mole of N2, and he added 3 moles of H2, and he added 1.98 moles of ammonia as well. So these were mixed together. So there might be some forward reaction. If there's forward reaction, NH3 would increase. There might be some backward reaction. Eventually, a time would come when equilibrium is reached. So the reaction might be going forward and backward, but a time would come when equilibrium was reached. It is reached in a sealed vessel under certain conditions. It was found that 1.64 moles of nitrogen were present in the equilibrium mixture. So at equilibrium, you have 1.64 moles. Those are your equilibrium moles. So what does that mean? You started off with 1 moles. Now you've got 1.64. That means an extra 0.64 moles came from somewhere. Like you got an extra 0.64 moles. So that means 0.64 moles they got produced during the reaction. Okay, because you started off with 1 mole and now you have 1.64 moles. So there's an extra 0.64 moles. So 0.64 moles got produced during the reaction. So there must have been some backward reaction so that more N2 is produced. Uh, Emma, is this clear? ठीक है, is this clear? Alicia, Aisha?
Yes,
Yes.
sir.
Achha, so there's an extra 0.64 moles coming from somewhere, and that means there must have been some backward reaction that would be going on. And so to produce 1 mole of N2, 3 moles of H2 are produced. So if 0.64 moles are getting produced, then according to the ratio over here, how much H2 would be produced? It would be into 3, that would be 1. What would it be? 1.92? Can somebody?
Yes, sir. 1 point.
So you're going to get 1.92 moles. They are going to be produced as well. And to produce 0.64 moles, 1 N2 is produced when 2 NH3 react. So according to the ratio, uh, double the amount. It's going to be 1.28 moles that would have reacted. That would have reacted or taken part in the reaction. So 1.92 moles of this is getting produced. So now you have an extra 1.92 moles. So you had 3 moles initially. Now you have an extra 1.92. So that means you have 4.92 moles, right? And over here, 1.28 moles are reacting. So that means there's going to be 1.28 moles gone. So out of 1.98, if you remove 1.28, what are you left with?
0.7.
Okay, so you're left with 0.70 moles. And so now you found your equilibrium moles, and again uh, it's a sealed container. What's going to be the expression for Kc? It's going to be uh, NH3 concentration squared, and it's going to be divided by the N2 concentration into H2 concentration, and that's going to be cubed. And that would give you 0.7. I mean, you only have one place where there is 0.7, so that's probably going to be A. It's going to be 0.7 squared divided by the reactants, which are 1.64 and 4.92. It's 3 moles, so it's cubed. Is this clear?
Yes.
Sir,
Yes.
isn't the formula products over reactants? In this equation, I think nitrogen and hydrogen are being produced. So
Nee, it's. Remember, the thing is that you're going to take the products as the ones on the right side, and you're going to take the reactants as the ones that are on the left side. I mean, you're going to follow this notation. I mean, I do get your point that there's more reverse reaction happening. I mean, that's what your question is, right? Which is why you're calling them the products, right? but you write the expression of Kc based on convention. The convention is anything that's on the right side, that's the product. Anything that's on the left side is the reactant. What the reverse reaction just indicates is that there's more reactants and less products at equilibrium, which is why you're going to get a smaller value for Kc. That's it. So the ones that's on the right side is always the product. The ones that's on the left side is always the reactant. Is this clear?
Yes, it's
And
clear.
also remember, because it's a reversible reaction, I mean, there is no forward side, there is no backward side. I mean, it's just the way you write the reaction. Like I could have written the reaction the other way around, it would still be the same exact reaction. So the convention is the right side one is the product, it should be in the numerator. The left side one is the reactant, that should be in the in the denominator. That's it. So just going to do a few more questions just because this is important. So this is exactly the same. Try and work this out. So he added what in the container initially? 2 moles of N2 and 6 moles of hydrogen, and he added 2.4 moles of ammonia. So it's going to be 2 moles of this and 6 moles of this, and it is 2.4 moles of this. Now, forward and backward reaction would start. The moles would change. And at equilibrium, it was found that there are 2.32 moles of nitrogen. So you have, at equilibrium, you have 2.32 moles of nitrogen. So that indicates that there's an extra 0.32 over here. So you have an extra 0.32 moles because you started off with 2. Now we've got 2.32. So an extra 0.32 moles got produced. So there must be some more backward reaction happening to give you an extra 0.32 moles. So what would be the moles of H2 that are going to be produced? What would you get? Can anyone answer this?
0.96.
Okay, so this one would be according to the ratio. If one is produced, 3 of these would be produced, so 0.32. So over here, 0.96 moles are going to be produced. So there's going to be an extra 0.96 moles, and the answer would be that you already had 6 moles. Now you have an extra 0.96. So at equilibrium, you have now 6.96 moles. And to produce these many moles of N2, 2 NH3 should react, right? So it's 1:2. So over here, how many would react according to the ratio it's going to be? 1 second.
0.64.
I think it's going to be 0.64. And these are the ones that are reacting. So they would be gone. So you subtract 0.64 because they're gone. So 2.4 minus 0.64. What do we have? 1.76?
Yes.
So we've got 1.76 moles. Now you uh, have your products and your reactants. So it's going to be 1.676 squared divided by your reactants, which is 2.32, and 6.96 would be cubed. So it's going to be the first one. Option A is going to be products over reactants. So it's going to be option A. So now I think we didn't do any difficult questions, right? Most of the questions we did were all very typical KC questions. So I'm going to try and do some slightly more difficult questions. So a few of them are, where are they? So this one, I think we didn't do this one. So let's start with this one. The first thing, uh, we just had a discussion on this, and that was that I told you that if there's a reaction, there's H2 and I2 reacting in equilibrium with 2HI. And there's another reaction, 2HI in equilibrium, right? Are these two different reactions or are they the same reaction?
Same.
ठीक है? I mean, they are exactly the same. Remember this, that in an equilibrium reaction, you can write the equation the other way around. It's because there's one reaction going forward, one reaction going backward, right? So it's a combination of two reactions. So this one and this one are exactly the same reactions. I've just flipped it around. I flipped the equation around. Remember, in equilibriums, you don't have a conventionally defined reactant. I mean, you could just change the product into reactant and reactant into product. It's up to you, whichever way you like to write it. And I said one more thing. If I balance this equation differently, and there's half I2 and half H2, is it still the same reaction or not? Is it the same reaction or not? I mean, I've changed the balancing as well. I mean, if any guesses, Mariam, any idea? Are these two reactions exactly the same or are they different reactions? So remember this thing. I mean, when you're trying to balance equations, it doesn't really matter how you balance them. Like if I have NaOH and HCl and they are uh, reacting, like if I have this reaction, forget NaOH. If I have this reaction, I've got Na reacting with two HCls and it's forming two NaCls plus an H2 gas molecule. And if I balance this reaction differently, there's Na reacting with HCl and it's producing NaCl plus half H2. Now remember, there are a number of ways of balancing an equation. I mean, these two are exactly a balanced equation is the ratio in which things are reacting, right? So these two are exactly the same equations. There's nothing wrong with them. They're exactly the same. The only thing is that they're balanced differently. Like over there, I just multiplied the whole thing by two. So balancing doesn't really matter. I mean, balancing is the ratio in which the reactants and the products. It's the simplest ratio, and you can simplify it further by dividing the whole thing by half. It would still give you uh, the same reaction. It's basically the same reaction. The way you're writing is different, but it is the same reaction. Is this point clear? Anna, Mayim, is this clear? Ahmed, is this clear?
Yes.
Yes.
I said so it doesn't really matter how you write this equation, whether it's the other way around, whether you write the reactants first or the products first, or you flip it around. A reversible reaction is a reversible reaction. Now look at the two reactions over here. Do you think are these two exactly the same reactions or different reactions? When he wrote reaction one and reaction two, are these exactly the same or are they different reactions? What's happening in the first reaction? So can anyone just make a guess?
They're the same.
TK, they are the same reaction because there's X2Y, that's on one side, and that's changing into X2 and Y2, right? Uh, Obviously, it's balanced differently. What's happening in the second equation? You still have X2Y and it's changing into X2 and Y2. So the only difference is that they're balanced differently. And X2Y is written on the right side over here, X2Y is written on the left side. So they're kind of they're basically the same reaction. So tell me another thing. If they are the same reaction, so would they have the same value of Kc or not? Like I told you, every equilibrium has an equilibrium constant, right? So they're basically the same reaction. So would they have the same exact value of Kc or would they have different values of Kc?
Different, I think.
ठीक है अच्छा it's but it should have, because it's the same equilibrium reaction, it should have been the same. But the thing is that Kc depends on what's in the products and what's in the reactants, right? So and how the equation is balanced, because you're balancing the coefficient becomes the exponent. So which is why the Kc value, I mean, there's going to be a relationship between the Kc values, but the Kc value is not going to be exactly the same because over here the product is different and the reactant is different. In the second one, the product is taken as different and the conventionally different and the reactant is different. So if I write the first Kc expression for reaction number one, I'm going to call it Kc1. It's going to be X2Y is my product and it's going to have a concentration and that's going to be squared divided by my reactant, which are X2, and that's going to be squared, and Y2 concentration power 1. So that's the expression for the first one. The expression for the second one is, now my products are different. So X2 concentration and Y2 concentration would be power half, which is under root because the coefficient becomes the power. So my products are X2 and Y2, and my reactant over here is X2Y. Now, now this one is these two are obviously different expressions, so the Kc value is going to be different. But the two expressions, they represent the same reaction. The only difference was that the equations were written differently, so which is why you get a different expression for Kc. But the two Kcs would be interlinked. There would be a relationship that would exist between the two Kcs. Now he gave you the value for Kc of reaction 1 as 2. So this is equal to 2. By just matching these two, can anyone tell me what the value for Kc2 is by just looking at this expression? I mean, what has to be done to convert this into this expression? The first thing is that x2y is at the top over here in the numerator, x2y is at the bottom over here. Is this clear? So it's everything is switched around. So what I can do is I want to convert this expression over here into this expression. So x2y is at the top over here, x2y is at the bottom. So I'm going to take a reciprocal of that. So it's going to become x2y would come at the bottom, and x2 concentration squared and y2 to the power 1 would go on the top. So I've just reciprocated, I've just inverted it. So it would be now equal to 1 by 2. Is this clear to everyone?
Yes.
So
So, sir, it will be in Kc2, it will, the 2 will become under root, right?
exactly. And the last thing is, now I want to convert this expression to exactly this expression. So I need to get rid of the square as well, right? So how do I get rid of the square? I take the under root. If I take the under root, the square is gone. This square is gone. If I take the under root of this, it would become half. And I'm taking the under root of everything. Now these two are exactly the same expressions. So Kc for reaction number 2, now these two are exactly the same expressions. So Kc for reaction number 2 has a value of 1 by 2 under root. That's going to be our answer. And that's what they were looking for. They gave us the Kc for reaction number 1, and they were asking us to find the Kc for reaction number 2. Is this clear?
Yes.
Yes.
So it's probably going to be the first one, A. So just remember the two cases were interlinked because they were just different forms of the same expression, because these two were the same reactions, except that the product was different. The products and the reactants were switched around. So the numerator and denominator positions were switched around. Plus, because the equations were balanced differently, over there everything was squared, over here everything was power 1 or half. So we converted the first expression into the second expression. I said, let's try and do this question as well. That there's a reaction that's going on, and we don't know what the reaction is. So it's all trial and error. So let's take the first one. That's P in equilibrium with 2Q plus R. And they gave us initial moles. What did they tell us? They told us that 2 moles of compound P were placed in a vessel. So 2 moles of this, and there is no Q, and there is no R. So these two are not there. So 2 moles of a compound P were placed in a vessel, and the compound P was partly decomposed by heating, and the dynamic equilibrium between P, Q, and R was established. So compound P partly decomposes. So we know that there's some forward reaction happening, and there would be Q and R that would be formed, and the amount of P would decrease. So at equilibrium, he's saying that X moles of R were present. So you're at equilibrium now, and once you open the container, he says that there were X moles of R that were present at equilibrium. So what does that indicate? That indicates. I said, so what does that indicate? That indicates that you had 0 moles, and now you have X moles. So how many moles got produced? An extra X moles got produced during the reaction. You started off with 0, but now you have X moles. So to produce X moles, they got produced. So to produce X moles of R, how many Qs should be produced as well? 1R is produced when 2Q is produced along with it. So it's 1:2. So over here, there's going to be 2x. So there's going to be 2x moles getting produced. Is this clear?
Yes.
And to produce 1R, 1P reacts. To produce XR, XP must react. So you have initially 0 moles, now 2x moles got produced. So there's an extra 2x moles. So at equilibrium, you're going to have 2x moles. And for P, you had 2 moles and X moles got reacted. So X moles are gone. So at equilibrium, you're going to be left with 2 minus X moles. So you found your equilibrium moles in terms of X. That there were X moles of R getting produced. There were 2 X moles of Q that were getting produced. And if X moles are produced, X moles would react over here as well. So that's X moles are getting reacting as well, are reacting over here. So it's 2 minus X left over here. The final thing is, he's saying that at equilibrium, the total number of moles present was 2 plus X. So you add them up. What's the total moles? Are you getting 2 plus X? I mean, over here it's going to be 2 minus X moles of P, and there's going to be 2X moles, and there's going to be another X moles, right? So I'm getting 2 plus 2X moles, which is wrong, because he was very specific that the moles at equilibrium were 2 plus X. Is this clear?
जी.
Yes.
ठीक है, बाकी मरियम, is this clear? Mahad, Aisha, Mariam, Nabila.
Yes.
So, so it's all going to be trial and error. You have to start all over again now. You're going to pick another equation. I think B is the right one. So you're going to pick another equation. Now that equation is going to have different ratios. Actually, so that equation. So I'm going to rub all of this. So at equilibrium, the mole ratio is going to be different. So let's do the second equation, which hopefully is the answer. As that one, the ratio is different. It's 2P, and there's 2Q and R. So everything changes now. And he said that at equilibrium, X moles of R were present. So there's an X moles present over here. That means an extra X moles got produced in the reaction. So to produce X moles, how many moles of Q would be produced along with it? That's 1:2. 1R is produced when 2Q are also produced. So over here, you're going to have 2x extra moles getting produced. And to produce 1R, there should be 2P reacting. So to produce X moles, there should be 2X moles of P that would react. So now at equilibrium, you'll have an extra 2X moles of Q, and you're going to have minus 2X moles of P because they're reacting. So you'll have 2X moles, and this would be 2 minus 2X moles. And the total moles at equilibrium, if you add them up, would be 2 minus 2X moles of P. You add 2X moles of Q, and you add X moles of R. The 2X are going to get cancelled out. Is this clear?
Yes.
Yes.
And that leaves you with 2 plus X, which is what he was actually looking for. 2 plus X. So hence B is the right option for this question. So we're going to do another question. This question is kind of very similar. It's exactly the same, except that he's now asking uh, for you to. And this one you had to do trial and error for each one of them because every time the ratio was different. So you had to figure out when would the information fit or match with which equation. So we're going to do some. Let's do one. Now here's a question. This one is so. This one is a carboxylic acid. If you remember the reaction, reacting with an alcohol, and it is producing an ester and a water molecule. Anyways, there's this reversible reaction going on. So it's saying ethanoic acid can be reacted with alcohols to form esters, and equilibrium mixture is being formed. So he even gave us the table. Like if you look at the table, the initial moles that are given are that there's 0.1 moles of ethanoic acid and 0.1 moles of alcohol that are added. And there is no ester initially, right? At the beginning, initial amount, there is no ester, there is no water. And obviously, there's a reversible reaction. So there would be some forward reaction. An ester would be produced, water molecule would be produced, and some of the alcohol and some of the carboxylic acid, they're going to get used up during the reaction. Now he told us to write the expression for Kc, so it's going to be product concentration and the units as well. So it's going to be product concentration, which is the ester, into the water concentration, and you're going to divide it by so you're going to divide that by the reactant concentration, which would be carboxylic acid and alcohol. Can you even tell me what the unit is for this one? Anyway, what's the unit for this expression? Nabila, any idea? France?
No unit, sir.
Okay, they're not going to be any units because the concentration times concentration divided by concentration times concentration, mole per dm cube, mole per dm cube, mole per dm cube, and mole per dm cube. So everything gets cancelled out. So no units for this. I said, but the last part. Now he's saying that in an experiment to determine Kc, a student placed together in a conical flask 0.1 moles of ethanoic acid and 0.1 moles of an alcohol. So you have a flask, and the flask has 0.1 moles of the alcohol, and it has 0.1 moles of the carboxylic acid. And we have no idea how much ester there is. And he also added a catalyst, which is HCl. Now remember, catalyst does not disturb the equilibrium position, so it doesn't do anything. So there's 0.005 moles of HCl, and the catalyst doesn't get used up. So remember the catalyst. And then the reaction starts. The flask was sealed and kept at 25 degrees centigrade for 7 days. After this time, The student. Now, what would happen after this time? That what's going to be produced is you're going to get some ester plus water molecules. So some of it is going to be produced. We don't know how much, but at least some would be produced when these two are mixed together. So after this time, the student titrated all of the contents with 2 mole per dm cube anyway. So what he's now doing is he took a burette and he started adding 2 mole per dm cube NaOH into a mixture that has now reached equilibrium. Like there's ester being produced, and the ester and the water are decomposing back to form alcohol and carboxylic acid back again. So he started titrating the whole mixture, and the volume of NaOH that was used was 22.5 cm cube. Can you even tell me the moles of NaOH? Because that's the first thing. How much NaOH was added? So N is equal to C into V. So it's going to be 2 C into V. So it's going to be 2 multiplied by what? 22.5. How many moles do we get?
0.45.
So basically, you're adding 0.45 moles of NaOH, right? It then says, so how much moles would react with what would the moles of NaOH, what would this NaOH that you're adding, what would it react with in the whole mixture?
Sorry, sir, it's 0.045.
Are you sure? ठीक है, 0.045. That's a 0.045 moles. Now, what would this NaOH react with? You've got NaOH. Now, the NaOH would react with two things. It would react with the acid. It's a base and acid. It would react with HCl as well. Is that clear? Because the NaOH does not react with the alcohol. It does not react with the ester. It does not. It doesn't have any reaction with water. The only thing it does react with is acids, carboxylic acid or HCl. So you're saying what amount? So remember, you're adding 0.045 moles of NaOH. So some of it would react with the HCl. So how much HCl do you have? You've got 0.005. And some of this would react with the acid, carboxylic acid. And so can you even quickly tell me what amount would react with the HCl? Like what does NaOH and HCl, in what ratio do they react? What's the equation? NaOH plus HCl, it's going to be NaCl plus water, right? It's 1:1. Is that clear? ठीक है, it's 1:1. Is this clear? Ahmed, is this clear? Mahad?
Yes.
Achha, so the point is that you're adding 0.045 moles of NaOH into this entire flask that has an alcohol, that has a carboxylic acid, that has an ester, and that has a water molecule. So HCl and NaOH react in 1:1. So if 0.005 moles of HCl are present, that means the amount of NaOH that is going to react with it is 1:1. It would be 0.005 moles. So out of the 0.45 moles that you've added, only 0.005 moles would react with the HCl that was added as a catalyst. What would the rest of the 0.04 moles react with? The rest of the 0.04 moles would react with the carboxylic acid that's present in the mixture. Is this clear? Anna, Aisha, Lishpa, is this clear? Mayim, is this clear?
Yes.
So we're going to continue with the same. Please remember this question so I can remember this. Let me just take a screenshot and post it. That we were on this question. Just 1 second. So just remember. चलिए, let's continue uh, tomorrow now. ठीक है? Okay, take care.
Okay, Allah.
Hafiz.
Allah Hafiz.
Hafiz.
Allah